All right, you guys, here we are where we left off, section 9.3. I'm going to do two different FRQ examples for means. This very first one, speaking of me telling my funny story about getting pulled over many times, did you know that you are supposed to only drive 25 miles an hour in a construction zone? So we have a very similar problem to the one that we talked about last class period. And what we're talking about here is we have a police officer and he's using a radar gun to clock people going through a construction zone. And we are asked a question about, do we have enough evidence to conclude something? Do we have enough evidence to conclude the average speed of drivers, we have a random sample of 10 drivers, is greater, there's our our null hypothesis is going to be mu equals 25. Remember, the null is always an equation. And this question is asking, do we have evidence to say people are speeding? One-sided. You can see my null and my alternate written right down here. Okay, first I'm going to define some stuff. Yes, I already have it all written out here, so go ahead and pause if I go too fast, friends and family. The x values, notice how that we use an x value when these are not proportions, right? These are like miles per hour for 10 different cars going through the construction zone. And the population is going to be all the cars in this construction zone, and we have a random sample of 10 of them, okay? And we are testing a claim here, not doing an estimate. That's what you do an interval with, is when you're asked to estimate something. Here we are testing this claim. And once again, the sigma is unknown, and that's why we're doing a 2-sample t-test. I'm going to go ahead and check my conditions real quick. Random and independent are very self-explanatory. Let's talk about the normal condition. It says nothing up here about having a normal distribution. Also, we can't apply the CLT because we only took a sample of size 10. Dang it. So I'm going to check this dot plot real quick. Here's what it looks like. And I don't see any extreme skew. I don't see any extremely obvious outliers. Yeah, this one is kind of far away from this and the rest of them, but I don't think it's super obvious. So I'm going to go ahead and proceed, and I'm going to say safe to use T. The formula on the formula sheet, look back into your notes in your reading guide. It reads on the formula sheet the words statistic, which is my sample mean I got from typing all these into my calculator. There's my X bar. Minus the parameter, you know that's the number from the null hypothesis, the assumption, divided by the standard deviation of the statistic, or the standard error of the statistic. This is my S sub x when I typed in all 10 of those values and did one variable stats in my calculator. And root n goes in the denominator, and we have 10 drivers here. That's my sample size. And please make sure that you're aware this is a T. This is not a Z, okay? Anyways, when I crunch this number in the home screen of my calculator, I get a test statistic of 3.051. And let's talk about, like, what does that mean really quick? Let me just draw a quick sketch right here. We have our null hypothesis of 25 miles an hour. That's the null hypothesis, goes right in the middle. And my sample mean was, what did I get? 28.8. Okay, so we have to decide, like, how far away from the 25 is the 28.8 that we got. Is that surprising? Is that high enough to tell us that we think that people are speeding? Or is it considered, like, not that far away? So we're actually going to calculate this p-value right here. And I'm shading to the right here because remember my alternate hypothesis means shade to the right, so that's why I'm going to the right. I don't have to worry about doubling or anything here because this is not two-sided. And if you think about it, this 3.051 as my test statistic is more or less a number of standard deviations for a t-distribution above average. So since this number is 3 standard deviations above average, actually more than that, 2, 3, we are a little bit higher than that. This p-value, how am I going to find it? Remember, next to normal CDF in your calculator, there's this thing called T-CDF. And so I'm going to do T-CDF in my calculator. Maybe I will write that here in order to calculate this number, T-CDF. Lower bound 3.051 to the right forever with 9 degrees of freedom. And it gave me 0.00688, which is like super low. That number is way less than alpha, so we are going to reject the null hypothesis in favor of the alternate. remember how to write your conclusion. Here is another example. Yes, hopefully you're comfortable now writing all of your conclusions, but we have, since the p-value, which is this number, is less than our alpha at 0.05, since nothing else was assumed, we reject the null in favor of the alternate, and I'm going to restate what the alternate says since I am in favor of it. I have rejected the null, I am in favor of the alternate, and what I'm going to do is write this in words. We have evidence, okay, that drivers are speeding through the construction zone. Another way of saying that is that the mean speed through the construction zone is greater than 25, okay? Don't mind the noise in the background. My family is watching Harry Potter. Okay. Given your conclusion in part A, what kind of mistake? Oh, snap. Type 1, type 2. We talked about that on day 1 of the chapter. Could you have made and explain what it means in context? This, my friends, is a beautiful summary right here. What we have is we have rejected the null. See, that's what we did up here. We rejected the null. If I had failed to reject with a larger p-value, then that's what I would write right here, okay? But since we rejected, that means by definition we could have made a type 1 error. Remember that a type 2 is when you fail to reject. And so what that means is if we rejected and we believe this, but that's an error, that means that we think people are speeding, but they're actually not. Can you fill those words into the blank, of the sentence? We think people are speeding. We think that this average speed is greater than 25 miles an hour in the zone, but it really isn't, okay? And do you think that you could just come up with a consequence there? A consequence of this would be, I don't know, maybe you're gonna tell more police officers to go clock people there and write tickets, even though it's kind of unnecessary because actually we made an error and the speed limit is not greater than 25? So that is something that you need to be able to follow up your conclusions with. That is kind of a recap of type 1 and type 2. And that concludes this example. And then I'm going to do this one in a separate video. Okay, love you guys. And shoot me an email if you have any questions about anything. And I will explain some more tomorrow. Good job. Have a great day.